Hi everyone. Today we're going to do a warm-up on the power rule and then go through an application. So our learning goals are to consolidate our learning of the power rule to find the derivative and to find the slope of the tangent at a specific point. And we're also going to learn to solve problems involving using the power rule to find instantaneous rates of change. So in our first question, state the derivative of each function. So we're given the function f at x and we want to find f prime at x. Using the power rule. So if you remember from Monday, we learned that you take the exponent, multiply by the coefficient. So 12 times 8 is 96, x to the, and then reduce the exponent by 1, 96x to the 11th, minus 2 times 14 is 28, x to the 1, which you don't need to show, plus 1 times 8 is 8, x to the 0, and x to the 0 is a 1, so you don't need to show that. And then the derivative of a constant like 10 is 0. So f prime at x would be 96x to the 11th minus 28x plus 8. In B, I would first rewrite it so that the 1/12 pops out in front of the x cubed to get it ready to differentiate. And now I would find y prime by multiplying 3 by a 12th. And you get 3/12, and then reduce the exponent by 1. And then 3/12 reduces to 1/4 x squared. So that would be the derivative. And then for C, again, we would first want to change it so it looks like a power function. So we want to bring the x up to the numerator. So first I would want to think about it as putting the root form into exponential form. So that would be 3x to the 1/4. But then I want to bring it up to the numerator so the exponent will become negative. So those two steps were just to get it ready to derive. So now I'm going to find y prime by multiplying -1/4 by 3, so that's -3/4, x to the 1 minus -1/4. So to get the exponent on x here, we need a common denominator of 4, so it would be 4/4, and then minus a negative is adding 1/4. Y prime is -3/4 x to the 5/4. But since the question was in radical form, we want our answer to be in radical form. So y prime would be -3 4th root of x to the 5th over 4. And recall from grade 11, if you have x to the exponent m over n, it means the nth root of x to the exponent m. So that's the exponent. And that bottom number is the root. Okay? So just going over those key things again. Question 2 is an application. So find the equation of the tangent line. So not just the slope of the tangent, but the equation of the tangent line to the curve y equals 2 root x at the point P 9, 6. So we're going to start with y being 2 root x, and then I want to write it in a form exponential form, so y equals 2x to the exponent of 1/2. Now I can find the derivative, y prime. So 1/2 times 2 is 1, x to the 1 minus 1/2, and a lot of you would just be able to go straight to y prime equals x to the 1/2 or the square root of x. Okay, so that gives us our derivative. But we want to know the equation of the tangent line at the point P 9, 6. So if we know that the slope of the tangent is the root of, at any point is the root of x. Then the slope of the tangent at this point 9, 6 would be the root of 9, which is 3. So we have the slope of the tangent being 3. And we have our point 9, 6. And we could use y equals mx plus b to get the equation of the tangent line. So we could put 6 in for y, 3 in for our slope. X is 9 plus b. And we can solve for b, the y-intercept. So b is going to be 6 minus 27, which is negative 21. So then therefore the equation of the tangent line is y equals, so our slope was 3x minus 21. So that would be the equation of the tangent line to the curve y equals 2 root x at the point 9, 6. Okay, 3 is an application question as well. At what point on the parabola y equals 3x squared is the slope of the tangent line equal to 24? So we're going to start with y equals 3x squared. Find the derivative. And then it wants to know where, at what point is the slope of the tangent 24. So y prime represents the slope of the tangent, so I want to know where the slope of the tangent is 24. Gives us a nice simple equation to solve. So we get that the slope of the tangent is 24 at an x value of 4, but we want the whole point, not just the x value. So our point's going to be 4 something. To get that something, we're going to use the original equation and substitute 4 in for x, which is going to give us 48. So therefore, at the point 448, the slope of the tangent is 24. There's a word problem. The population of a bacteria culture is given by the function p at t equals 500 plus 200t plus 12t squared, where time is measured in hours. What is the population at 4 hours? So that just wants to know the population p at 4 in hours. So we just need to find p at 4. And we can enter that into our calculator. And we get 1,492 bacteria. So at 4 hours, there would be 1,492 bacteria. Now we want the average rate of population growth over the first 4 hours. So over the first 4 hours means from time equals 0 hours to time equals 4 hours. So our average rate is going to be p at 4 minus p at 0 over 4 minus 0. And p at 4 we found out was 1,492. P at 0, so if you sub 0 into this equation, you're going to get 500 over 4. So 1,492 minus 500, 992 over 4. So the average rate is going to be 248 bacteria per hour. So there's our average rate. And then C, what is the growth rate at t equals 5 hours? So because it doesn't ask over a range, it just asks at a specific place, 5 hours, that's going to be instantaneous rate of change, which involves the derivative. So if we know P at t is 500 plus 200t plus 12t squared, we need to find P prime at t, excuse me, first. So the derivative of 500, it's a constant, is 0. Here we have an exponent of 1, so the derivative of 200t is 200 t to the 0, but t to the 0 is 1, sorry. Plus, here 2 times 12 is 24t to the 2 minus 1, which is 1. So our derivative is p prime at t is 200 plus 24t. But we want to know p prime at 5. And p prime at 5 turns out to be 320. And again, it's a rate, so it needs units, bacteria per hour. So that is our warm-up, and I have some practice questions for you to do. Thanks.